Okay. Well, welcome everybody to the third session of the course. As usual, we will start with a small summary of what we have covered and what we will cover today. In the first classes, we see the basic data structure of the language. There is where a lot of the power of Python resides. In this second class, we see the control structures, very common, very normal, usual as many language. Maybe the interesting part there was that, for example, the for and while loops were a little bit different. We saw most of the reserved keywords. The only reserved keywords that we didn't cover in
Test
the
results came out good, 255 for Hong Kong, 170 for the other one, but
170.
yeah, but
Raluca, your microphone is on.
oh, sorry.
Yeah. The only two keywords that we didn't cover in the last class were how to define function and the class keyword, and that's what we cover in this and the next section. And that's why, because they are very, very important, and there's a lot of things to say about them. So here we go. We already use the def keyword, that is the keyword used by Python to define functions. So we saw the basic structure. Yeah, it's nothing unusual. Def, the name of the function, the argument, and then the series of instructions that we already see in the previous lesson. But here we are going to begin to see some peculiarities of Python that also give them a lot of power. So, for example, one thing that Python has that not a lot of other languages have is the function command. This is a feature that Python installed. I think it was from Lisp. But as you can see, if the first line of a function is a string, that string has a particular meaning, and it's that it's a comment of the function. It's a document of the function, and that value, that string, is stored in a property of the function. Here in this example, we use the multi-line string, but we could use simply a single string. For example, we can use our friend some function, and we can say some values. So here we have the doc string of the function. Also, it's important to know that in Python, functions are first class values, and functions are objects. That means that of function sum, as any other object, has a lot of methods and attributes that are accessible to it. And as you can see, here we have fundoc with, if we get it, will give us the, the document string. The idea of document string is precisely to document the function. You can use the same type of command that used, for example, in PHP and in our projects to indicate the arguments and the return value. There are some libraries that use this string to add a test. So the testing library reviews all the document string of the functional classes and execute them to have the documentation and the test in the same place. That's a very nice. And as you can also see, well, you have, for example, font name. So what would be the name of some? Some, of course. In this case, it makes no much difference, but of course, we can get this function from a parameter, a variable, and in this case, we still have the original information. Okay, so we have that first element of the function. The other thing that I would like to talk is of course, we see the return expression. In Python, you can have a function that doesn't have return. That's the same of having a function with an empty return. And that's the same of having a function that returns the known object, because the known object, as you already know, is the object that represents no value. So,
Jose, sorry, I have two questions regarding what you're writing now.
Yeah.
First is, can you redefine functions really in scripts as you did before, like with this blah function?
yes, exactly. I was going to talk about that in a few minutes or in the next class, but yes, that's true. As you know, for example, in language like Java, you have things like this. Of course, here I don't going to write Java code, but in Java, you can say, for example, this, and you can create another function, or in the case of Java, another method with several, with different kind of parameters, and you end with two different functions. In Python, that's not the case, because remember the philosophy of Python. When you have a script, when you import the script, the first time that you import it, every single line of that script is executed in a namespace, and in that namespace, all the variables, all the definitions are created. So if we have this in a file and we import that file, when Python see this first line, it will understand, oh, I must create an object of type function with this body, and I will name that object with the name sum. So when you get to this other line, you are overwriting that name, and this is the function that remains. So that's very important. In Python, you can only have one name associated to one function in one namespace. So multiple definition, the last one overrides all the previous one, right?
Mm-hmm. Okay, so there is no option to disable this functionality.
No, that's for design. That's done in that way.
Okay,
On
then
purpose.
next question would be about using reflection and annotations. Is there some kind of library or method
Ex-
to read other comments, arguments, and so whatever?
Excellent question. And yes, also that's part of the philosophy of Python, and one of the reasons because Python is so powerful, in my opinion. As you can see, we already saw it, but I overrode the function already. Yeah, as we already know, a function is an object. An object has attributes and, and methods. And we already know how to get those attributes and how to get those methods. And that's how reflection works in Python. We see in the first class how dictionaries work, how to access to the key, to the values, and the no so dirty and no so secret about Python is that everything is a dictionary. So if you understand dictionary, you understand reflection, you understand the module system. And we already see that, for example, this attribute of the function gives us a document string. We can have we can have access to the code of the function, and what's more, we can compile in real time code and assign it to a function. And look at, for example, this one. Look at this. This property is what how its name implies, a dictionary associated to the function. So you can make arbitrary annotations to the function using this function dictionary. You can use it, for example, for make memoizing, so to store previous values of a function that are very expensive to calculate and things like that. Another example interesting is found defaults that we will see in a few minutes. But yes, if you understand dictionary, you can make access to all the elements of a function, all the elements of an object, all the elements of a class, and you can manipulate them. Yeah. I think that will be that will be the next point we will talk about. Okay, we see that our function have a document string. We see that our function is an object with a lot of attributes and methods that we have access to it. The other interesting aspect of a Python function is the default parameters. Python stole this from Lisp. Now JavaScript, the last version of JavaScript, it has 6 stole that from Python. The idea of default parameters, as its name implies, is that you can assign the value of a parameter, and once you do that, you can omit that parameter in the invocation. So you can say sum p, of course, that is the normal invocation, or you can say sum of 2. In this case, A takes the value 2 and B takes the default value. This is very powerful, and this is the reason why, or this is one of the reasons why Python doesn't accept function overloading. In the case of Java, in Java, you would create a series of functions with the same name, with different number of parameters. You'll have the most generic function, and then you will define, for example, another function like this. This is the way on which you will do it in Java. Create a generic function with a lot of parameters and create a specific function with less parameters and passing the default values to the general one. In Python, this is not necessary. In Python, we use default values directly. Right? The only thing to take in consideration is that once you use a default value, the next parameters must have default. If you try to do this, you get an error. Once you write the first default parameters, all the rest will be default parameters, right? Okay. The second element in a function is the positional argument. This is also a feature that originally appears in Lisp, that also language like C have it. And it gives Python the possibility of accepting an arbitrary number of parameters. When you declare a function like this, let's do it more interesting. When you declare a function like this, the first thing is that you can omit this parameter. You can say 0.2. And as you can see, the value of C is empty. But the idea is that a C variable can contain, in this case, a tuple of all the remaining values. So you can say you see what happens? A goes to A, or the first value goes to A, the second value goes to B, and a tuple is created with all the remaining values of the invocation of the function. Yeah. One thing that we didn't see in the previous definition was was this one. Do you remember function defaults? Function defaults has a tuple with the defaults of the parameters. As you can see, since we already know that the defaults are the last element of a function definition, we don't need to specify that this is the default value of B, because there's only one default value, and the default values are at the end of the declaration. So if I have two default values here, then the first one will be for A and the second one will be for B, right? Okay, so this is the positional argument. The other interesting thing about Python is the keyword argument. The keyword argument, they have the same structure, just that instead of having one asterisk, it has two. And what does it do? As you can see, in this case, the value of C is, what is this? Anybody can tell me?
Empty dictionary.
Exactly. This is an empty dictionary. So maybe we can guess what can go here. This can be a simple value because some way it has to end in a dictionary. So what this does is that we can add arbitrary name parameters to a function. You see? Everything that goes, everything that has a name and a value end here. Also notice that naming the parameters, it's a perfect valid option. You could invoke blah in this way. Or so when you invoke any function or method in Python, you have the option of indicate the name of the parameter, and that name, the name of the argument, and that name must be equal to the name of the parameter. Of course, there are some rules, but those rules you don't need to learn because they make common sense. For example, you can begin without using a name and then specify the name of the parameter, right? But if you do something like this, you get an error because we are telling that the first argument must be present in the invocation. And in this case, Python doesn't have any way to know uh, what the value of A is. So as you can see, you can begin making an invocation without names, but once you begin to use name, you must keep using names. Or you can make the invocation using names, but you must fill all the values that are needed. So are we good here, right? Okay. As I was telling you, Python doesn't have function overloading. That's by design because the file is read sequentially, and def well, it's a reserved keyword, but we can understand def again in the context of a dictionary. Def creates an object of type function in the current environment and assign a name to it. So if you have two or more function classes methods with the same name in the same namespace, only the last one will remain. Okay. The other thing, and that's why Python is not exactly a functional language, is that it doesn't have tile call optimization. That means, and we saw it in the first class, that when we define the factorial function, uh, there are some language, uh, specifically the functional language, that when they look at this function, they see that the last invocation of this function is the function itself. So they preprocess the function and convert this recursive invocation in a loop. Python doesn't do that, and that's the reason why. If we try a number very big, we got maximum recursion get exception. Right. This normally it's not a problem because the depth of the stack is big enough for the normal cases when you are not using this kind of declaration. It's something that you must take into consideration, right? So these three elements, the possibility of giving name to the parameter, to the arguments in the invocation of the function, having default values, having positional arguments that allows you to invoke a function with an arbitrary number of arguments, have keyword arguments that allows you to pass arbitrary keys and values. That gives you a lot of power, a lot of expressive power, and make that your code would be very, very clean. Yeah, for example, another example is that when we create a dictionary, for example, if the dictionary, all the keys are strings, we used to do things like this, right? Okay. But given that we have keyword arguments, we can say things like this. and it's the same thing. You see, at the end of the day, there's a very, very close relationship between dictionaries and objects. And you can think that in Python everything is an object, or you can think that in Python everything is a dictionary. Okay. We already talked about global locals and bar functions in the previous sections, in the previous sessions. And you know, the idea is that locals return the dictionary of the current context. So if you invoke it locals inside a function, you get what are the variables that are defined inside that function, that method, or that class. And globals returns a dictionary with the variables that are defined not in locals, but in the wrapping environment. And again, these are dictionaries, so you can do whatever you can do with dictionaries. If you use locals and add a keyword and a value there, it's the same thing as if you were creating a local variable. Of course, this is useless for creating local variables. You can create the local variable directly, but we can use it, or it will be more exact to say to abuse it to create or to modify the global environment. Please don't do it, but you know that you can do it. And that's also an interesting point with Python, that one of the mottos of Python is that we are all consenting adults. Python won't stop you to blow your foot if you want. It only will tell you, dude, it's stupid to blow your foot. So it's stupid, for example, to change the globals variables inside a function, but you can do it, right? Okay, we are
Sweet.
going to, yeah. We also are going to talk about decorator, that it's also a very nice feature of the language. I'm not sure if Python took this from Java, or it was the other case. But as you have seen already, in Python, functions are first-class values. That means that we can assign functions to variables, and then we can call them. And that's one of the reasons why functional programming it's a powerful tool, because you can store functioning variables, and then you can manipulate those variables and create new code. Well, one interesting application of that philosophy is the use of decorators. The first thing to take in consideration is that these decorators don't have anything to do with the decorator pattern. There are different things. But the idea of a decorator is an expression that takes a function and returns another function. Of course, you can write a function that does that without any problem in Python from day zero. But those functions are used for a very particular purpose, and have a very interesting sugar That is, that you use those functions to manipulate function to modify in certain ways. And I don't know if you are familiar with the aspect-oriented programming. The idea of aspect-oriented programming is that you keep separate the concerns. There are certain functions that have to do several unrelated things. You need a function, for example, that evaluate if the user has the permission to execute it, to log the parameters that are passed to the function, that execute that function, and that log the result. You can write those things as separate function and then create a new function that invoke authorization, log, execution, and log. But that's an acceptable solution, but in some way that hides the core of the problem. The core of the problem is do the job of the function, and the log and the authorization and separate elements that must be processed separately. And that's what a decorator does. A decorator allows you to modify a function to do any change to that function that you are interested. So we can see it in this example that I'm going to write in the course.
Is this example working?
Well, yes, almost.
I see that it's not past second parameter. So
yes, it lacks a line here, and we are going to see why. But I need to correct that this slide. But the idea is the following: we have our function, our dir function sum. Now, let's say that we want to modify this function so it returns the value that it must return +1. So how can we do that? Well, we can do it the old way, for example, right? Yeah, that works. But if we need to do this thing to add 1 to a lot of functions, so we would like to abstract this pattern, right? So the next option that we have is to write a function that take a function and evaluate it and return the result +1. The next possibility is that we can say, for example, this. We can take any arbitrary function, A and B, and then we can say in the sum that looks a little bit better, but it still is not what we want, because as you can see, every time we want to use our sum function, we have to surround it with the decorator. And that's not what we want. What we want is to change sum in some way that it returns what it was supposed to return plus 1. So the functional solution would be this one. We can write an int function, like an arbitrary function, and here we need to return a new function, right? That's what we're going to do. So we define a new function. It doesn't matter his name. In this case, we can say A and B, or we can do it more generically. And what does this function is going to do? This function is going to invoke the function that we passed and return its value plus 1, right? But what I missed in this slide is that, of course, we must return the function blah. Now, look what happens with I do this. The int function is taking one function, in this case sum, and is returning a new different function. That different function invokes the original and returns plus 1. Returns the value that the original would return plus 1, right? So we can now say, for example, sum2 equals 2, and sum and we have our goal. We create a new function that returns the same as the original plus 1. What decorators do is add a little bit of syntactic sugar to that. We really don't need to create a new name for that function. We want that it has the same name. And that is what this syntax does. You see, when Python sees this, it knows that it has to apply the int function to the sum function, and that the result will be called sum. So we end with a sum function modified by int. And the nice thing is that you can put as many decorators as you want before the function. They are invoked from the closest to the farthest. So if you put foo, bar, bas, first bas is invoked, then bar, then foo, right? Decorators are very nice. We will see its application in class in the classes, for example, to modify the class, to add static methods, getter, setters, that kind of thing. But also you can use it to for aspect-oriented programming. Yeah. Okay. That's the basic decorator. But of course, we can go a deeper level. And that deeper level is a decorator that accepts parameters. In this case, our decorator only took the function and returned a modified function. But what if I don't want to add 1 to increase by 1, but in some cases I want to increase by 2, by 3, by 5, by any arbitrary number? So here the things get a little bit complicated, right? Well, but not much, because all we need to do is to wrap all this code in a new function that takes this argument and return it here. And that's what we did here. You see? This is, okay. This is the original solution that we have, but instead of using +1, we use +n, and +n gets from here. Yeah, so int returns a decorator, and that decorator is then applied to this function. I know it's a little bit confusing the first time that you see it, but well, first you won't need it to use it very frequently, and second, once you write 3 or 4 of these, it becomes simpler. So this is the basic of the function in Python. That's what gives their power. The other thing to add to this one is that, of course, we already saw it, that Python can return multiple values. Yeah, and that's it. Now, if any question from you?
Can you, Jose, can you show the second slide of decorators, please?
Yes. The important thing to notice here is that this from here to here is almost identical to the first decorator. Yeah, you see, we have a decorator. We create a new function that invokes the first plus certain modification. And that original code, it's involved in another function that makes the modification. So this kind of decorator, you can think about a decorator of a decorator, or more precisely, the parameterization of a decorator. Yeah. In the first case, you invoke it without any argument, because the syntactic sugar knows that it will invoke int passing as an argument soon. Here it's almost the same. Here you are invoking int n passing 5, and int n must return a decorator that takes the function, in this case sum, and return a new function. Yeah. Okay. Well, that's all from the theoretic standpoint. If there are not any questions, I think we can take a break and return to 8 minutes to get practical.
Okay, thank you.
Of course, since I'm sharing my screen, maybe my Hangout conversation will be recorded. My Slack conversation. Raluca just sent a link of understanding Python decorator
Yes.
in 12 easy steps.
They're
Well-
not easier at all.
Exactly.
12.
When you need more than 30 steps,
Yes. So I was reading that. I'm even more confused now.
yeah. Yeah, no, but the idea is a function that take a function and return a function.
That I get. That I get. The rest I don't. The actual implementation. The theory sounds great.
Yeah.
It's the practice that kills me.
Yeah. Yeah, and the problem is that if you want to parameterize,
Parameterize. Yes.
exactly one decorator, so you need to pass passive parameters. So you have a function that take parameters and returns a decorator. So a function that take parameters and return a function that take a function that return a function. It's a
It's
toxic.
a vicious circle. It's a.
Yeah.
So why is it called a decorator?
Yeah, that's
Makes no
because-
sense to me.
exactly.
Well, it has a little bit in common with the pattern decorator. The
Exactly.
pattern decorator also wraps inside the object on which you implement the function of the first object and then the second object. So it goes also as a layers and layers.
Exactly. There's a pattern in the kind of force that does that with objects. And very confusingly, the Python guys decided to use the same name.
Great. I think we're all back, at least in Amsterdam office.
We all ready?
I think so.
I'm back too.
Okay.
Me too.
Okay, so we can start again. Okay. Perfect. Now we are going to make some exercise about functions. We, since day one, have been making exercise about functions, so we know how to create them. So this exercise will be more of the new functionality, the optional parameters, the extended list of parameters, and function as first class values. So let's start with positional arguments. And we need a voluntary.
I can go for it.
Okay, perfect. The idea, and this is just the warm up, is that we need two functions. One function that take an arbitrary numbers of elements and return its sum, and one function that gets an arbitrary numbers of elements and return its product. That's it. It's just one more for the next step.
Okay. 1 second, I'll share my screen, right? And then we go. Oh. Can you see my screen?
Yes.
So we do arbitrary amount of arguments. and we do return something. Two stars, I think it's for vocabulary, for keyword arguments, and this one is for normal arguments. And then we have, I don't know, args summary. There is something on the tuple which should return me.
In the tuple, well, whenever you have that kind of question, you can go to the console and type there and try to see if there's a method in the object.
Okay, it's tuple, right? And on tuple, I need to check what arguments there are.
Exactly. There's not a method in tuple to sum all his parameters.
What? No method on tuple to check all the parameters?
To sum all the parameters, there's not.
Okay, so we go.
Yes, you can use the sum function, or that could be a nice opportunity to introduce another function that is reduce. If you go to the console and get the help from reduce, maybe you can get it.
Reduce? What reduce?
Yes, reduce is a predefined function in exact.
Okay. Reduce what was here.
But reduce is okay. It's a function. You'll get all the parameters of a function.
Parameters only?
Yeah. As I told you, it's better than when you want to get information about a function and object, you use the console and get help there.
Okay, I have console opened.
Okay. But
1 second, I'll share it. Yes.
So say just one question.
Yeah.
What is the question actually?
Excuse me, I didn't hear you.
What is the question exactly? What we have to do here?
Yes, we are beginning with a function that takes an arbitrary number of arguments and returns its sum. Okay, and there we have the help of reduce.
Is it clear now?
Yeah. I think, yeah.
Well, but this is part also of the process. Since we are going to need the help of Python, we need to get familiar of how it gets the information. But as you can see, reduce first it's a function that it's very common in the functional world. It's a higher order function. All functions that take function are higher order function. So the decorator, for example, a higher order function. And as you can see, it takes as a first element a function. And it's a function of 2 arguments. As a second element, it takes a sequence. So it takes a tuple, a list, a dictionary, or a string. And it could take an additional element that it's the initial value or the empty value. And what the reduce does is that it applies the function to the initial value and the first element of the sequence. It gets a value and then apply the function to the result plus the next element of the sequence until the sequence is complete. Praja has made it using has given us a solution using the
Well,
the
the
normal.
using the right. Yeah.
I just
normal.
look at my second thing. I just created one function with arg, that passing the initializing sum equals to 0, then checking till I is there in the arg, that is arbitrary variable, and then getting the sum equals to sum plus I.
Yeah.
And then
Okay, Alex, do you think that you can use reduce?
Yeah, of course. 1 second.
And reduce is one of those functions that really take advantage of lambda, for example, because in this case, we need a function to add two numbers. And yes, we can write that function wherever we want, but since it's a very it's a very simple function, we can do it as Alex did it. Okay.
1 second. It complains about the function. I don't know why reduce. Do I need to include some module?
You are using Python 3. Python 3, I think that it removes reduce from the built-in.
See.
So, yes, please use Python 2.
Oh. 1 second. What do I need to include? You should
Just
recommend-
shebang change to.
No, it will not. It will work only like this from the console, but not from the. Let's see.
Yeah, perfect. You can add a third element in reduce, that is what they call the initial value, and that's useful, for example, for empty list, or we will see it in the case of the multiplication. Okay.
What do you mean
that-
third element?
Yes.
There are three elements.
Okay.
So there
You
is-
have the function lambda, you have the sequence, and you have a third value that is the initial element. Exactly. Make that test. As you can see, the initial element is used at the beginning of the calculation. If you have an empty list, you return the empty element. But in this case, since we are talking about summation, the empty element is 0. It's the default value. We can, well, no, it's not the default value, but we can omit it.
Okay. Yes. Like
Okay.
Cool.
Okay, that was half of the warm-up there. We
Yeah.
need another function that does the same, but with multiplication.
Awesome.
Yes, but we need two functions, one for sum and one for multiplication.
Come on.
Isn't some keyword?
Yes, there's a sum function, but
We can
there's
override it,
problem.
Right?
Exactly.
Why not?
Why not?
Perfect. Okay, that was only the setup, because the goal of this exercise is another. Now we are going to write the real function, and the real function is write a function that gets an arbitrary number of elements, and using sum and mult, return the sum of the even numbers and the product of the odd ones.
What?
You want the sum of the even and the multiplication of the odd.
Okay, sum of even numbers, multiplication of the odd.
Exactly, but exactly. Very nice. But my madness has a reason, as you will see
Okay.
in a few minutes.
Miss colon.
What?
Colon.
Ah. Stupid Python.
This is already course 3.
You can do like this.
Perfect. Or you could have said, if not, E modulo 2. The two are equivalent. There's no reason to choose one or another.
What we have. Ah.
Very nice.
Ah.
And exactly. What happened there and why did we get
Traceback model type unexpected operator type S for int and list. Okay, then it's for.
let's do something to debug that code.
Okay, so this is list, right? And we need not the list but arguments.
Exactly. Do the rest catch what was the problem?
Yes.
Yes. The problem is that the function sum and the function mult expect a series of arguments, expect an arbitrary number of arguments. Before correcting, Alex, can you please print the value of args in sum and mult, and let's see, no, but not in the where function. Exactly. And okay, since this is not Python 3, we don't need the print is not a function.
Why not use it like a function in a proper way?
Well, you can put parameters around it, but it's an expression, it won't be a function. Okay, of course, we only printed one before we get the error, but here it's more clear what is happening.
Mm-hmm.
When sum of odds are invoked, one parameter. So the variable args, it's a tuple with one parameter. The first parameter, it's a list, and when we try to reduce that list, we are summing 0 to a list, and we get the error. So we need a way to unpack the odd and the even variables. And it's very, very simple.
Okay, there should be some function, Jose. There should.
Yes, much better than a function. It's syntax. What you need to do is to add an asterisk in the invocation of the functions, in sum and in mult.
Wait, here? Like this?
Exactly.
And what does this do?
Exactly. As you can see, there's a symmetry between the declaration of the multiple arguments in the function and the invocation. Yeah. When you put an asterisk in the in an argument in the invocation of the function, what you are saying is take that variable that is a sequence, and instead of being one argument, it'll be as much argument as you want, right?
Okay.
Okay, that was the purpose of this exercise. because you couldn't get that error. So now you see the cost and what's the solution. Okay, the positional arguments were covered.
Jose, I have a question. How to pass by reference in this case?
Okay,
How it's using like passing by reference in Python?
okay, but are we talking about this specific case or?
No, I'm just talking about syntaxes. Usually similar syntaxes is used for passing by reference in languages.
Yeah. Well, the idea is that since Python is an object-oriented language, uh, when you pass not primitive values, but when you pass objects, uh, you are passing. It's not exactly reference. It has another name, but it's very similar to reference. When you pass an object, if
It's a
you
pointer,
modify,
kind of a pointer, right?
yes, it's a little bit like a pointer. It's a, but it has a technical term. You pass a copy of a pointer. So if you make a change in the object, you are making a change in the global environment. But if you assigned a different value, that assign affect only the local variable. Are we in the same page?
Yeah. It looks like a pointer.
Yeah. Okay.
So if you pass immutable objects, you have only local copies of that objects, right, inside the function.
Yes. If you pass an object, any change that you make will affect. Okay, but an immutable object, for example, if you pass a tuple, and you try to add elements, you'll get an error because a tuple is invariable. But if you pass a tuple of object, the tuple is invariable, but the objects aren't. So you can modify the values of the objects in the tuple, but not the tuple itself.
Okay.
You cannot add, remove, or change which elements are in a tuple. But if the tuple, if an object, for example, an object that represents a person with name and surname, you can change the surname of the person. If the tuple is a dictionary, if the tuple has dictionary, you can add and remove keys and change values of that dictionary. As long as the dictionary is the same, the tuple hasn't changed. Okay. For the next problem, another voluntary. The next
Why
problem.
you don't like me, Jose, or what? Why?
The next problem, it's very simple. It's to write a function that take a function and print his name and his dog string. So of course, we need also a demo function for it. Who would do it?
Eduardo said he wants to do it.
Yes, I can try.
Okay, perfect. So can you share your screen?
Yeah, let's. Here. This one. Okay, where is this?
Okay. As usual, we'll begin with a warm-up. We need a function with a dog string.
Let's warm up. Warm up.
Exactly. Can you increase the size of the text so we can get a better video.
Wait, yeah. Where can I do this? View.
I don't know if Control Shift
Yeah,
Plus
that's what I was trying. No,
didn't work.
no. No. Apparently it's not working. So you are not able to see, right?
Well, I can see, but the idea is to have it clearer in the video. But
Yeah.
okay, but
I'm not
yes,
able to.
keep going.
Okay. So let's warm up. We need
Exactly.
so what is the goal? Can you show me?
Okay, let's start with that warm-up function. Can you add a doc string?
Yeah, okay. So something like warming up,
Exactly.
something like that.
An interesting note, as you know, a function needs a body. The body can be passed or can be returned, but the docstring counts as body also. So you can define an empty you can define an empty function with a docstring, for example. Okay, perfect. We already have our warm-up function. Now the real object of this exercise is to create a function. No, okay, no, leave it alone. Leave it as it
Okay.
is. This is the function that I want you to create. A function that takes a function and print his name and his docstring.
A function that takes a function. So
Okay.
we're gonna need somehow the decorators, yeah, something like that.
Well, look that we don't need decorator. It's as direct as it says. We need a function that takes one argument and print certain information of that argument.
Return.
Did I see?
No. Return. We need what is the function that will help it's the something like it's the function doc, right?
Yes, it's the name of the object dot the name of the argument we're interested. But okay, but I see that your argument is a positional argument. It's a
Let's
and we don't need positional argument here. We need only one simple argument.
okay. Function. Oh. Yeah, this is an argument, something like this, and return. Return the function the doc of that argument. So
Okay. Yes. Remember that the Python interpreter is your friend. If you don't remember what what's the name of the attribute, you can use the Python interpreter.
Well, we use in the beginning of the first second, we use this something like this, right? Or some function name.
Yes, you need a function to see what are the attributes of the function.
Mm-hmm.
So if you don't have any, you need to create one. Or you
Okay, for instance, something like this. Return blah blah blah. And now no, no.
I'm not looking at your console. It's covered by all our faces. Okay,
Name. So
but
these are the
Click outside the faces, Jose, and then it should disappear. So click on the screen upper. At least on mine, it disappears.
no, here it doesn't.
No? Okay.
So I'm in the Python interpreter, and I see this func doc, func global, func name.
Exactly, those are.
Yeah.
So
So if I'm passing an argument A to a function, I should be able to return A something. But how can I do this here?
a dot func name a dot.
Yeah, that's what I was trying, but suddenly this disappeared.
Yes, but
Because it doesn't know its type. That's why it doesn't give you highlight.
exactly.
Autocomplete.
Yeah, okay. There's no intelligence in there. Okay.
Yes,
So
that,
it's something like this.
yes, that's a problem, but with Python, that since it's a dynamic.
Okay, I understood now. I understood because I was trying that before, and I was not getting there. So that's why I gave up. Okay.
Yeah, but the name and the doc stream.
Okay, not the function name, but the okay.
Both.
Both.
Yeah.
Wait. So function name, for instance, could be a dot function name, and function doc could be something like function like this, and return both.
Yeah.
Can I return something like this?
Exactly. And you need
No.
for testing purposes. Exactly.
Yeah, print some print f form.
Okay, we can see in the last line warm up and warm up function. Perfect. So the goal of this exercise was simply to have written our first high order function. So we wrote a function that take a function and somehow, well, this is not a high order function, excuse me. This is just metadata. We are getting the metadata of the function, right? So now we can go yes to the first value. Yeah.
I have a small question. There are these properties like func doc and func dict, but also there are magic variables like underscore dict and underscore doc. Are there differences?
I think that in the beginning, I think that dog was the same that
It's the
as
same.
fun dog.
It's the same.
Yes, but I think that that has to do with making some names more clear. Yeah. But for example, the big underscore big, it's more general. That's a property that has that all the it's a protocol. All the object that has a dig, well, all the objects have a dig with the properties of that object. Yeah.
You mean dictionary?
Yes, a dictionary.
A
So
dic-
it's there are certain special methods.
What you were thinking about, Victor?
I heard that property has a dick, so I was interested.
Uh, maybe a mispronunciation or something like that. Okay, but now we are ready to function as first class values. And of course, we need another voluntary. I don't know, someone with a strong mathematical background.
I can go. I can go if you don't mind, Jose, because I understood you don't want me to go.
Perfect. Okay. Again, we are going to need two functions, f and g, that take one argument. That's our one map. So can you write a function that returns the square of a number and a function that returns the number plus one?
Yeah, 1 second. I share my screen and I go with the functions. Do you see my screen?
Yeah.
Square, right? Function. And the second function plus one, or what? Right?
Exactly. Takes a number and returns the number plus one. Perfect. Those are simple for the basic for the exercise, because the real exercise is to write a composite function, a function that takes two functions and return a new function, a function that applies the second function to an argument and the first function to the result of that second invocation. So the function composition in mathematics, right?
Okay, so that's about, and you want me to use these decorators as we discussed, right?
No, here we are still talking about a function, a higher order function. We need just a function that takes two functions.
Okay.
Exactly. Well, remember, it takes
Okay.
two arbitrary functions. Exactly. The only thing we know about those functions is that each one takes one argument and return one argument.
Okay. Okay. We take also some argument here.
Okay, but one second, Alex. Remember that the goal is to write a function that takes two functions.
Oh,
We
okay,
don't
I
know
forgot
which
what we were
function
doing.
are these.
Okay. We take the functions and we return new function. Right.
Exactly.
Like this?
Perfect. Exactly. And let's see if it works. We can try to compose a square with ink and the contrary. Exactly. We took 2, we incremented is 3, and we square it, and it's 9. And let's make also the opposite. Let's apply a square first and ink later. No, compose is perfect.
The funk.
Yeah.
We
So
want to create a new composition.
okay.
Okay, can you
1
execute it?
second, I don't know, something is not working. No. Yeah, clear why. I think there are some with my
There's a problem.
keyboard.
Okay,
I
but
don't. I think
Don't
Yeah.
you allow up?
you can run it
it
in the
doesn't work.
console.
Yeah, I'll run it in the console. 1 second.
But anyhow, it's perfect.
Well, yeah, I run it in the console. It works. It returns 5, but
Perfect.
I don't know why.
The nice thing to see here is that, okay, it's that of the higher order function that in this example, func, it's a new function created dynamically using other two functions, square and int, and the same with func2, and we can create arbitrary combination of function in that way. We can manipulate function, and that gives us a lot of power. Yeah. And now,
Frankly speaking, I would hate this person who tries this kind of code in a real project, like returning functions of functions in functions.
yeah, but
Yeah, it's
no,
really confusing, but I think
Right.
it's for mathematical purposes, it's useful.
yeah, no, of course, when you first find this idea, it could seems a little bit useless, but once you get used to that, it's very powerful. In fact, for example, Google MapReduce is based in this concept. MapReduce is an infrastructure to parallelize data processing. And the idea is that you write a simple function that make a little bit of the processing of the data that you want. And MapReduce connect those functions one to the other, to the other, to the other, and does it dynamically. And if you enjoy using, for example, list comprehension, the idea of list comprehension it's the same. It may not seem like that, but behind the scenes it's just map and reduce, applying a function to a list that creates dynamically another list that can be applied to another function that filters elements of the list. So you have written just once the list comprehension code, and after that you can apply it to several, to whatever function you want. Once you start using this kind of code, you don't want to get back to the old ways.
Isn't it called closures?
Well, the
Is it same like in like JavaScript, for example?
Yes, JavaScript has it from the beginning. It has closure. Closure is certain kind of this. With closure, you have a different version of the same function with different parameters. That's basically what a closure is. But when you have variables that can be functioned and you invoke those variables, that is when you have the higher order function. Right. Okay, and we need a voluntary for our decorator exercise. Anyone?
I can go again.
Oh.
Now you have the right contact.
Yeah.
You increase the type of font. Perfect. Well, because it's very fortunate that you do it, Eduardo, because we are going to write a decorator that prints the name of the function before it executed. So the screen is all yours.
Okay, so let's see. Mm-hmm. Okay.
Okay. Notice.
Good enough?
Yes.
Okay.
Can we see the function that you wrote before? That
Yeah, I
print?
have this
Okay.
one. Okay.
Okay. And it's the if function does 90% of the work of the decorator. We want a function that it's a decorator. It prints the name of the function and then executes it normally.
Okay, so let's see if we can. A decorator. So a decorator without arguments.
Okay, that's when you invoke the decorator. First, you have to create the decorator that is a normal function.
A function.
Okay, but let's give the decorator a name that somehow indicates what it does. let's call it, I don't know, print function name, something like that.
And that's what I F name. Okay, you want to print. Okay, print function name, like this.
As a commentary, in Python these days, Python prefers the use of underscore
Okay,
to,
like the old days. Okay, so like this.
okay.
So you want something here, the function name, for instance. You want an argument. So this is the function. Now,
Okay. This could help everybody because decorator generally has a very normal structure. So a decorator is a function that returns a function. Exactly. So exactly. Can you leave the leave empty the arguments for 1 second and make that function return pass or return not.
the decorator function?
Yes, put pass there, exactly. Okay, and okay, get out of here. The decorator must return that function. We haven't ended to write the decorator yet.
I know. So, like, warm up. F.
Okay, but let's go step by step.
Okay.
Okay, please delete to those lines. Okay. I was telling that a decorator has a very regular structure. Okay, we define the decorator. In this case, the decorator takes a function, defines a function, and then returns the new function. Exactly. That's the structure of the decorator. What we need to modify in this structure is that function decorator that is there. Well, and the first thing that we can do is that which parameters should accept the decorator, that function when you are right now, when your cursor is right now. For example, would it make sense that I put A, comma B there?
No.
Exactly. It won't make sense because if I put A, comma B there, that decorator will only function with
two arguments.
Function take two arguments.
Yeah.
So what's the most generic thing that I can put there?
The most generic thing, something like what is the args pointed to a list of args.
Exactly. Well, almost, because with that we cover an arbitrary number of arguments, but we still need to cover the keywords arguments. So the most generic thing that you can put is asterisk R, comma, double asterisk.
Yes, and this.
Exactly. With that, we can accept every function in the world.
So now
okay, but you don't need to define anything else. And now you
return now it's return args.
Okay.
Wait.
Yes. Here is where things begin to be specific. In this particular case, this decorator that we are writing right now, what we want to do is Before executing the function, we want to print his name.
Say it again, Zé.
We want to print the name of the function before executing it.
Before executing. So, do I need to? But this is inside the decorator as well.
Exactly, because the problem is the names. The decorator is print function name, and what you name decorator is just an auxiliary function. It's the function that will replace the decorated function.
Print FM. Wait.
We want to print the name of the function.
Yeah, I know, but it's the function something like this.
Exactly. But we also want to execute the function as normal, as usual.
Return. What is missing here? Yeah, return.
Wait, that's outside the decorator.
Return. Fan. Arcs.
Yeah. We are very close, exactly.
Okay.
And the keywords argument, how do you pass them? Exactly.
This is a little bit strange still for me yet, but anyway.
Yes, but in the declaration, def decorator asterisk arc, we are declaring that arcs it's a variable number of argument, and key arc is a keyword argument. And no, you have it well. You have it right. How the way you have it.
Okay, so it was
Exactly. Okay. Here, you are not declaring a function, you are invoking it. And when you write fn asterisk arg, you are saying, I'm invoking fn, and the variable arg, that it's a tuple, I want you to unpack it for the invocation. And the same thing for the variable key args. Okay, we have defined our. Can you please delete the f function?
This one?
Yes. Yes, delete.
Wait. Yeah.
Okay. Okay. We have our example function, our warm-up function. We need to apply the decorator to the function. How do we do that? Okay. Not exactly. The arroba, the first character in that line, it's a syntactic sugar that it's used to automatically apply the decorator to the function that follows. So that arroba means apply the decorator to the function definition below it.
Okay,
so you don't need exactly, and as you can see, you don't need the invocation in this case. Not even exactly. Not even the two the two
Brackets.
brackets. Yeah.
Okay. This.
Yes, because that's what the arroba means. The arroba means take print function name and invoke it passing as a only argument warm up.
I saw that the print function name is receiving a parameter here, so that's why I was invoking. Okay.
Yes, that makes sense, but
Doesn't need it. Okay.
exactly. But the idea of decorator is to save you from typing that, and we need one line more to test it.
Yeah. Of course. Yeah, this is the worst.
Can you see that it printed warm up?
The function name.
Exactly. As you can see, the decorator makes the impression of the name. You don't need to put print in that last line. That print that you put was the one who was printing
It's inside the decorator.
the known. Yeah. Perfect. Of course, it takes a little bit of time to assimilate this information about the decorator and all that. But the important thing is that higher order function. That's the one thing that is most important to get home.
Jose, I have one question. So in real-time scenario, when do we use this decorator?
Yes, in fact, I have a project where, as I commented, it was a project for handling users in a database, in an LDPA database. So the user were created, modified, the password was changed, and there was a number of administrators that were allowed to do those changes. So I used decorators, one decorator to log all the parameters that were passed to the function that do the job. So we know that Fred Smith was the one who changed the password of the user A32. We use the same decorator to print the result of that command, and another decorator to verify that Fred Smith has permission or not to change that user password, and even a third decorator to take a function and convert it in a command. So the idea is that you could see in one file, or you could see the function more clearly, because you have the function that changes the password, and the only code that you see in that function was how the password was changed. You didn't have the authentication authorization, you didn't have the log. You only have that function and the decorators over it that say log it and make the check of the authorization.
And then someone creates decorator on top of your decorator, and then there is bug, and then you spend
Exactly.
two weeks
Ages.
to find the typo. Yeah.
Well, there's a risk on that, but
Just
yeah, in my case, it went well. So with this, we conclude this session. In the next one, we will talk about class. We'll see everything that we need to know, everything that Python have to offer from classes and object-oriented in general. And well, thank you guys, and see you next week.
Thank you very much.
Thank you.
Jose.
Thank you, Jose.
Thank you.
Thanks.
you.
Goodbye.
Enjoy the rest of the day.
Thank you.